Assalamu alaikum, dear students. Today our topic is P block elements, and from P block elements we will discuss group 15 elements, their their atomic and physical properties and electronic configuration along with their occurrence. So, what are P block elements? Elements in which the last electron enters the p orbital of their outermost shell are called p block elements. Like other elements, the properties of the p block elements show variation due to their due to the variation in their atomic size, atomic or ionic radii. That means their properties depend upon the atomic and ionic radii, their ionization enthalpy, their electronegativities. Now we have to study group 15 elements. The elements of the group 15 or the nitrogen family are nitrogen, phosphorus, arsenic, antimony, and bismuth. Collectively, these elements are called nicogens. And their compounds as niconides. As these are derived from the Greek word derived from the Greek word nicomig, meaning suffocation. Now, the occurrence of these elements. क्योंकि ये एलिमेंट्स जो हैं group 15 elements, these are also called the nitrogen family. These group elements of this group is called nitrogen family because the other elements follow nitrogen, which is the first element of group 15. They are also called nicogens and their compounds niconides because this nicogen is derived from a Greek word that is nicomig, means suffocation, as these elements are creating their suffocation. They are creating suffocation. Now, occurrence. First, nitrogen. The first element, nitrogen, exists as atomic molecule, diatomic gas. It constitutes 78% by volume of atmosphere. And in spite of this, it is not abundantly found in the Earth's crust, and it is only 33rd most abundant element by mass present in Earth's crust. It occurs mainly as nitrites, e.g., potassium nitrate, sodium nitrate. It is also an essential constituent of proteins, amino acids, and nucleic acids, which regulate the growth and maintain the heredity, maintain public control in the effects in living species or living organisms. This was all about nitrogen. Now the second is phosphorus. ये जो nitrogen है ये it exists as diatomic gas as N2. It is 78% by volume present in the atmosphere. It is not abundantly found in the Earth's crust, and only it is present up to 33rd most abundant element by mass in the Earth's crust. It mainly occurs in the form of nitrates like potassium nitrate, like sodium nitrate. It is an essential constituent of proteins, amino acids, nucleic acids, which regulate the growth and maintain the control the hereditary effects in living species. Now, phosphorus. Phosphorus is very reactive and therefore it does not occur in the nature in free state. It is a very reactive element and does not occur free in nature. mainly occurs in the minerals of hepatite family. It is 11th most abundant element by mass present in Earth's crust. And the minerals from which this phosphorus exists, the different which exist in the form of the apatite in the form of apatite family are: number one, fluorapatite, Ca3PO4 whole twice CaF2. This is 3 times. Or we can write Ca9PO4 whole 6 CaF2 whole thrice. Number second is fluorapatite. It is Ca3PO4 whole twice CaCl2. Number third is hydroxyapatite, Ca3PO4 whole twice CaOH whole twice. So these are the minerals of the apatite family in which this phosphorus occurs. It is the main constituent. It occurs in the animal and plant species, and it occurs in the bones, teeth, and living cells. So this was all about the phosphorus. Now, antimony, arsenic, antimony, and bismuth. These are not abundantly found in the nature, and so these exist in the form of sulfides. These exist in the form of sulfides. AS FeASS Fe2S3 Bi2S3. These are sulfides in which these arsenic, antimony, and bismuth exist, but in small traces. Now, electronic configuration of group 15 elements. Most important, electronic configuration element, atomic number, electronic configuration. This is complete. इसके बाद with noble gas core. Before writing the electronic configuration, I will write जो आपने 11th में पढ़ा है आबाज प्रिंसिपल, द एनर्जी इंक्रीजिंग एनर्जी ऑफ द ऑर्बिटल. We will write the order in which the orbitals electrons are filled in the orbitals according to their increasing energies. Suppose I will write it like this. According to Ahmad's principle, we have to fill the orbitals according to the increasing energies of these orbitals. So we have first, this is having according to Ahmad's principle, 1s has lowest value of n plus l value, so it has the lowest energy. So 1s, 2s, 2s, उसके बाद 2p, 3s. From this 3s, 3p, 4s, now 3d, 4p, 5s. इसके बाद 4d, 4d, this is like this. Four D के बाद 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, 7p. This is the increasing energy of the orbitals. So we have filled the orbitals according to their increasing energy. While writing the electronic configuration, you have to keep in mind the increasing energy of these orbitals. Now I will start from here. Element, atomic number, electronic configuration. First is nitrogen. The atomic number of the nitrogen is 7, so its electronic configuration is 1s. So s orbital, s subshell has one orbital, that is s orbital. इसमें दो electron, 1s2, 2s2, 2p3. You must keep in mind that the outer electronic configuration of these group 15 elements is their outer electronic configuration, outer shell electronic configuration is ns2 np2 to 6, where ns1 to 6, sorry, n is equal to n is 1 to 6, it is 2 to 6. So this is electronic configuration of p block elements. ns2 np1 to 6 electronic configuration of p block elements. Now the electronic configuration of group 15 elements is ns2 np3, n is equal to 1 to 6. This is outer shell electronic configuration of group 15 elements. Now we will see how this is the outer electronic configuration while writing the electronic configuration of these elements. 1s2, it has 7 electrons while filling the electrons in the orbital 1s2, 2s2, 2p3. So this is the outer shell is 2, second shell, this is 2s2, 2p3, n is equal to 2, 2s2, 2p3. Or with the noble gas core, it is electronic configuration will be helium. It has 2 electrons, helium, that is 2s2, 2p3. इसके बाद phosphorus, its atomic number is 15. Now it is electronic configuration है, इसमें 2 इलेक्ट्रॉन s में 2, p में 6, क्योंकि p में 3 ऑर्बिटल्स है, p सब शेल में 3 ऑर्बिटल है, px, py, pz, सो 2p में हम 6 इलेक्ट्रॉन फिलअप करते हैं, s में 2, p में 6, d में 10, it has 5 degenerate orbitals, so we can fill 10 electrons. Similarly, f has 14, we can fill 14 because it has 7 degenerate orbitals, so we can fill up 14 electrons in the f orbitals. So 15, that is 1s2, 2s2, 2p6, 2, 6, 2, 8 और 10, 3s2, 3p3. You can see that with the noble gas core. इसके बाद आएगा हीलियम, दिस इज नियॉन, नियॉन का एटॉमिक नंबर 10 है, सो नियॉन 6, 8, 10, 3s2, 3p3, 3s2, 3p3. Here, while writing the electronic configuration of the phosphorus, the value of n is 3, so the outer shell electronic configuration is 3s2, 3p3, 3s2, 3p3. So this is the electronic configuration of the phosphorus. पहले हमने s में 2, 2s में 2, p में 6, s 3s में 2, 3p में 3. Now nitrogen, phosphorus, arsenic. Now arsenic has, we will add 18 and 15, 33 electrons. It is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4s2, 4p6, 5, 4p3, 2, 4, 10, 12, 6, 18, 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p3, 2, 4, 10, 12, 18, 28, 30, 35. So with noble gas core, helium, neon, argon. Argon has 18 electrons, 6, 8, 8 और 6, 14, 15, 16, 17, 18 हो गए 18, and then we will write 3d10, 4s2, 4p3. अगर इसको हम इससे कंपेयर करेंगे, यहाँ तक 3p, इसके बाद 3p के बाद पहले हमें 4s भरना था, 4s हमने भर दिया, 3d कंप्लीट है, 3d10 कंप्लीट है, 4p, 4p3, तो यहाँ तक. लेकिन यहाँ हमने इंस्टेड ऑफ राइटिंग 4s पहले लिखने के बजाय 3d पहले लिखा, क्योंकि پہلے تو ہمیں 3D ہی 4S ہی فل اپ کرنا ہے، اس کے بعد 3D کرنا ہے، اس کے بعد 4P، لیکن یہاں تک لاسٹ میں 4P میں 3 ہی. تو یہ اکارڈنگ ٹو انرجی اکارڈنگ ٹو سیکوینس آف دا شیلز 3D پہلے لکھا اور 4S بعد میں لکھا. اب 3D میں بھی 10 الیکٹران، 4S میں بھی، یہ دونوں کمپلیٹلی فلڈ ہے، دونوں کمپلیٹلی ہم نے فلڈ لکھے، اور 4P میں 3 الیکٹران. اینٹمنی اس کو 18 اور ایڈ کرنا ہے، سو 51. So its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 5s2, 5p3. اس میں with the noble gas core ہیلیم، نیون، آرگان. ہیلیم میں 2 18 18 اور 18 ہیلیم، نیون میں 10، اس میں 18 ہیلیم، نیون، آرگان، کرپٹان. تو کرپٹان میں 18 اور 36، تو 36 اس میں ہے، 2 4 10 12 18 28 28 اور 30 30 36. تو یہاں تک کرپٹان آتا ہے. تو اس کے بعد we have to write krypton 4d10 5s2 5p3. This is with the noble gas core. چاہے ہم ایسے اس میں فل کمپلیٹ الیکٹرانک کنفگریشن لکھیں، چاہے ود دا نوبل گیس کور لکھیں. دس از ود دا نوبل گیس کور. ناؤ نائٹروجن، فاسفورس، آرسینک، اینٹیمونی، بسمتھ، وہ ہم یہاں لکھیں گے. ایٹامک نمبر 32 اس میں ایڈ کرنا ہے، ہو گیا 83. پہلے کمپلیٹ لکھیں گے. سو 1s2 2s2 2p6 3s2 3p6 3d10 4s2 4p6 4d10. اب میں 4f15 لکھوں یہاں ہی، 5s2 5p6 5d10 6s2 6p3. تو یہاں پر you will see that in antimony the outer shell electronic configuration is 5s2. Here the value of n is 5s2 5p6. Here it is 6s2 6p3. پہلے میں یہ کلیئر کروں، اس کے بعد with the noble gas core میں الیکٹرانک کنفگریشن لکھوں. یہاں پر ایک چیز سبوں میں نے ڈیفرنٹ کیا کہ سیکوینس کے حساب سے میں نے تھوڑا چینج کی. کیا چینج کی؟ دیکھیے 1s2 2p6 3s2 3p6 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 کے بعد پہلے 4s لکھنا تھا، میں نے 4s بعد میں لکھا. 3d10 3d10، اس کے بعد 4p6 4p6 5s2 لکھنا تھا، 5s2 آ گیا. اس کے بعد 4d10 4d10 5p 5p بھی آ گیا، 6s 6s بھی آ گیا، 6s بھی آ گیا، 4f 4f بھی آ گیا، 5d 5d. تو یہاں تک یہ کمپلیٹ ہے. اس کے بعد 5d کمپلیٹلی فلڈ کرنے کے بعد ہمیں 80 الیکٹرانز آتے ہیں. تو 6p میں 3 الیکٹران آتے ہیں، 2 2 और 2 4, 4 और 6 10, 10 और 2 12, 12 और 6 18, 18 और 2 20, 20 और 10 30, 30 और 36, तो यहाँ तक 36, 36 और 2 38, 38 और 10 48, 48 और 6 54, तो 54, 56, 56 और 14, 56 और 14 आते हैं 70, 70 हो गए 80, 83, 83, पी में 3 83। सो क्योंकि ये यहाँ तक सभी कम्प्लीटली फिल्ड हैं, अब क्या मैंने किया, इंस्टेड ऑफ राइटिंग 6s यहाँ पर लिखने के बजाय मैंने 6s लास्ट में लिखा, अकॉर्डिंग टू द सीक्वेंस ऑफ द शेल्स, फिर मैंने अरेंज इनको किया। ऑलरेडी आप पहले ऐसे लिख सकते हैं, उसके बाद आप सीक्वेंस लिख सकते हैं, लेकिन मैंने सीक्वेंस के हिसाब से ही लिया, क्योंकि लास्ट में 5d कम्प्लीटली फिलअप करने के बाद 6p में 3 इलेक्ट्रॉन रहते हैं, तो अकॉर्डिंगली तो ये कम्प्लीटली फिलअप के बाद 6p में 3 इलेक्ट्रॉन आते हैं। तो अगर हम विद द नोबल गैस कोर लिखेंगे, विद द नोबल गैस कोर, तो यहाँ पर क्रिप्टॉन, अब जेनॉन, जेनॉन में 54 इलेक्ट्रॉन्स हैं, तो 54 हो गए। इसके बाद कितने बचते हैं 29, 54 जेनॉन में आते हैं, तो 54 के बाद दिस इज 4f14, 4f14, 5d10, 6p3, तो 29, 24, 27 और 6s 6, क्योंकि 54 यहाँ तक आते हैं 6s2, 6s2। This is with the xenon noble gas core. This is 54, 54 or 14 हो गए 68, 78, 80, 83. This is how we write the electronic configuration of xenon with the noble, electronic configuration of bismuth with the noble gas core, keeping writing the xenon with and completing the electronic configuration. इसके बाद now this electronic configuration is important in the sense, अगर आपको अब ग्रुप 16 एलिमेंट्स या 17 या 18 एलिमेंट्स के का इलेक्ट्रॉनिक कन्फिग्रेशन लिखना होगा, यू विल राइट, ये 15 का है, 16 का NS2 NP4 आता है। सिमिलरली आउटर शेल इलेक्ट्रॉनिक कन्फिग्रेशन, दिस इज 15, ये 16 का, 17 का NS2 NP, बिकॉज दीज ऑल आर p ब्लॉक एलिमेंट्स, NP5, 18 का NS2 NP6, so we can substitute the value of n from 1 to 6, तो ये इलेक्ट्रॉनिक कन्फिग्रेशन आ गए। नाउ एटॉमिक एंड फिजिकल प्रॉपर्टीज, atomic and physical properties. First is atomic and ionic radii. Second is ionization and third is electronegativity. will write again the elements nitrogen, phosphorus, arsenic, antimony, bismuth. This is 7, 15, 33, 51, 83. This is group 50. अगर हम ग्रुप 14 लिखें, कार्बन, सिलिकॉन, जर्मीनियम, टिन, लेड. अगर इसका एटॉमिक नंबर 7 है, इसका 6, 6, 14, 32, 50, 82. Atomic and ionic radii. The atomic radii or the covalent radii of the group 15 elements is lesser than that of the group 14 elements corresponding group 14 elements, because as we move from left to right in the periodic table, the atomic size in a particular period goes on decreasing. This is because with the increase in atomic number, the new electron enters the same shell and the nuclear charge increases, and the nuclear charge more and more attraction takes place. This is why the atomic size decreases, covalent radii decreases, or the atomic radii decreases as we move from left to right in the periodic table. So group 15 elements have smaller covalent radii as compared to corresponding elements of the group 14. But as we move down the group, the covalent radii increases because the number of shells with the successive element increases. But there is prominent increase in the covalent radii from nitrogen to phosphorus because of the shielding effect of the s and p orbitals. Whereas in case of from arsenic to bismuth, the covalent radii increases. There is small increase in the covalent radii because of the poor shielding effect of the D and F electrons in the D and F subshells. Now, ionization enthalpy. The ionization enthalpy of the group 15 elements are higher as compared to the corresponding elements of the group 14. This is because of their smaller size, their stable electronic configuration in which their outer p orbitals are completely half-filled. So, when we remove the electron, we have to supply more energy as compared to the corresponding group 14 elements. But as we move down the group, the ionization enthalpy decreases because the atomic size increases, the number of shells increase, the atomic and the covalent radii increase. Just like the trend in the atomic radii or covalent radii, the same takes place, the same trend is followed by the ionic radii. So, ionization enthalpy, because what is ionization enthalpy? It is the amount of energy required to remove the most loosely bound electron from the outermost shell. Now, in the outermost shell of the group 15 elements, they have the p orbitals which have one electron in each p orbital. So the p orbitals are completely filled. So we have to apply, which give them more stable electronic configuration as compared to their group 14 corresponding elements of the group 14. So we have to apply more energy to remove the electrons. So the ionization energy of the group 15 element is higher as compared to the group 14 in a particular oxidation state. But as we move down the group, as the atomic size increases, so the attraction of the nucleus towards the outer shell electrons also decreases. So we have to apply lower energy to remove the outermost shell electrons. That, in other words, we can say the ionization enthalpy decreases. Electronegativity, because of their smaller size, because they need lower electrons to complete their outermost shell to have the noble gas configuration. So the electronegativity of the group 15 element is higher than the corresponding group 14 element. But as we move down the group, the electronegativity decreases because the atomic size increases. And the nitrogen has the electronegativity value of 3, whereas this phosphorus, arsenic, phosphorus has 1.9, 1.8, sorry, it has 2.1, 3, 2.1, this is 2, this is 1.9, 1.9. These are the electronegativity values of the group 15 element. So as we move down the group, the electronegativity decreases. Thanks.